Hello, my lovely viewers. Let's take a quick look at this question. This question we are asked, which quantum number determines orbital shape? Which quantum number determines the orbital shape? Now, when we look at quantum number describes the property of an electron in an atom. How the property of electron in an atom, that is what we call quantum number. And there are four major quantum number which are being expressed here. The first one is called principal quantum number. This is what we call principal quantum number. Principal quantum number. And principal quantum number determine the energy level of an atom. In other words, the size of an atom is what? Is principal quantum number. And this principal quantum number, remember, has, look at now, if I should write like this is a shell of an atom. All right. In fact, the shell of an atom is principal quantum number, the number of shell. All right. So this one is called the K shell. The first shell is called the K shell. So we have the K shell. If I should write another one called what? The K, we have L, we have M, we have N, we have O, and so on. Now, how do you determine the number of electrons in each of these shells? Now, if you are asked how many electrons are in K shell, simply use this formula, 2n raised to power what? 2. Where n is the number of shell. For instance, the first shell here is what? Is 1. So 1 raised to power 2 is what? Is 1. 1 times 2 gives us what? 2. Means that K shell has a maximum number of 2 electrons. Do you understand? So principal quantum number determines the number of shell. In other words, the energy level of an atom. Going further, the second one here, you call it azimuthal quantum number, or you call it angular momentum. Azimuthal quantum number or angular momentum. This angular momentum determines the orbital shape or the shape of the orbital. So our answer is what? The shape of the orbital is called angular momentum or azimuthal quantum number. Do you get that? Now this azimuthal quantum number has values. The values, we have a value of 0, we have 1, we have 2, we have 3. Now this the value, which is L, represented as L, has what? Has subshell. Has what? Subshell. The subshell of this one, subshell is what? This one is X. This one that is 1 is what? P. This one that is D, and this one is called B. That is what we call SPDF, used in electronic configuration. Have you watched a video of quantum number? Principal quantum number is being discussed extensively. It has a video on its own. Azimuthal quantum number, which is the second one, has a video on its own. Magnetic quantum number has a video on Ojemike channel. Look at Ojemike on YouTube. Look, go there, go and search quantum number. They will give you a detailed video. Now, this S now is, remember, S stands for sharp, P stands for principal, D stands for diffuse, and F stands for fundamental. Do you understand? Now, this S now has a name. The shape, remember, this one has to describe what? The orbital shape. What is the shape of this S? The shape of this is called spherical. It is spherical in shape. Spherical in shape. What is the shape of this one? The shape of this one is dumbbell. Dumbbell. Dumbbell in shape. What is the shape of this one? The shape of this one is double dumbbell. Double dumbbell. Or you call it clover leaf. Or clover leaf. That is the shape of this one. Why this one? The shape of this one is called complex. Complex, multi-complex. Do you understand? Now, how many electrons can occupy each of these subshell? Each of these subshell, how many electrons can occupy? each of these, for you to know the number of electrons that can occupy, just use this formula: 2 bracket 2L plus 1. Where L here is what? Is this one 0 plus 1. Now, if I want to look at the one that the S, what is the S is what? 0. So 2 times what? 0 plus 1 will give us what? Will give us 1. Now 1 times 2 will give us what? 2. So the number of electrons that can occupy S share is what? Is simply 2. Do you get that? So this one, the number of electrons is what? 2. This one is what? 6. This one is what? This one is 10, and this one is what? 14. So just use this formula to determine the number of electrons that can occupy each of these shells. Do you understand? Now, the first one here is magnetic quantum number. This one has to do with the orientation of the electron in space. The orientation of electron in space is what? Magnetic quantum number. This one here is called spin quantum number. This one has to do with the direction of the electron. The direction of the spin of the electron. When we have spin up, spin down. Spin up, look at spin up is plus half, and spin down is what? Minus what? Minus half. For more of this video, don't forget to like. Importantly, follow this page and share for the latest update on the world of chemistry. Thank you and God bless you.